This is the last part of the water pollution chapter. This is really, really important because this is a big issue up here. I heard Ms. Shirley talking to you earlier this morning about chromium-6 and the Hinckley story. We've got some amazing stories. The Hinckley story is the biggest water pollution lawsuit and mitigation project in world's history, as far as I know. In terms of, they told us last time we were out there, I think 200 people still working on it. And it's a huge project. And it's something we're working on. We also, now for our water class, water management class that I'd highly recommend to you guys as a follow-on class, we go there. We also have the world's one of 2 or 3 wastewater treatment plants that will be completely carbon neutral. And also one of the few in California that go to tertiary treatment. So write this down, this is really important, tertiary. I'll try to spell that for you, T-E-R-T-I-A-R-Y. That's really important because they don't do that in LA. As sophisticated as those people from LA think they are, in terms of wastewater treatment, they kind of stink, literally, right? They send stinky water out into the ocean and let the ocean dilute it for them, and that's pretty stinky. Right, okay. All right, water pollution means it's contaminated with chemicals, but we can also think of it being excessive heat, okay? So old times, what we used to do with power plants, if you go to San Luis Obispo, if you went to San Onofre when the nuclear plant was there, they put them close to oceans because they cooled their towers and everything with water. And so they actually would put warm water back into the ocean. So water heated can actually also be a pollutant. It'll change what the water is supposed to be like, right? So that's a form of water pollution. But generally, we're talking about contaminated with chemicals, and or it's a little bit misleading because it could not just chemicals, it could be biological. Could be our own waste, could be at the dairies we're going to be visiting, could be animal waste that can potentially pollute the water, okay? Point sources come from a specific spot. You know, as you're looking at let's pick a dry cleaner. Dry cleaners use a lot of solvents, and they actually, when we had one of our students that was the quality control person at Victor Valley Wastewater Reclamation Authority, they actually pinpointed one of these point sources. So late at night, they all of a sudden started getting this really nasty increase in a certain solvent in the water. And they eventually tracked it all the way up the system, and they came to a dry cleaner that was dumping their waste late at night. That's a point source, okay? Non-point source, we've talked about this as in other senses before. It could be a whole cropland. Could be all the area down where we see this a lot and where it's very relevant is the Salton Sea, okay? If you remember, we went over this very quickly, but Coachella Valley is a major vegetable producer, probably the biggest in the United States. And they use a lot of vegetables and a lot of vegetables. They use a lot of fertilizers, synthetic fertilizers and pesticides, and those can wash off. But they're not coming from one farm or one area, they're coming from a wide area. So that's non-point source, okay? Golf courses. You could look at that either point source or non-point, but it's coming from a big wide area, okay? All right, largest polluters, guess what, my friends, my guys, my people, agriculture, sediment, fertilizer, livestock waste. So that actual sediment from soil erosion that Tony was talking about yesterday is an actual pollutant. What kind of effect does sediment have? Give me an example of what's the problem with having brown water? You see it everywhere. That's just got a bunch of dirt in it. What's the problem?
Doesn't it choke out the fish? Doesn't it take away the oxygen?
Exactly. It literally chokes them out, could kind of smother them. It doesn't take the oxygen out. That's more if it's some kind of nutrient. Then the algae grow up and they cause a dissolved oxygen deficit. We're going to talk about that in a second. But the one that you really look at, and this is a really big problem, is on the coral reefs. Okay, on reefs. And so they, at the Gulf of Mexico, as the Mississippi comes out there, and any other place in Australia, I remember, fortunately, one of the most beautiful flying trips I've ever had was flying along the east coast of Australia, going up to a place called Cairns, where the Great Barrier Reef is, right? And as you fly along, you expect the barrier reef to be close to the land, right? It's actually way out. It's about 20 to 30 miles out. As you went up, you could see the rivers coming out, and you could see the little cones of where the sediment was going out into the water. If that gets out further enough, it can actually literally fall on the reef and smother it. At least basically smother it. They can't get oxygen. You're right about that part, but it's not that they're using oxygen, just smothers it. Okay. So anyway, so that's agriculture, industrial facilities, organic, inorganic, and organic chemicals. Okay. Organic just means it was at some point living. That would be like nitrates. Inorganic would be it's man-made, it's made from minerals and that kind of stuff. Mining, sediments and toxic chemicals. You guys have been to Mitsubishi, and we didn't talk about a heck of a lot up there, but they've also got very strict water control. As we drove up in our van, I don't know if I mentioned it, but to the right is the Cushenberry Springs, one of our really cool little riparian spring areas, and they have very strict controls about what come out of that mine can go into that spring. As you found out, actually, very little contaminations come out of it. Actually, because of the cement process, even things like mercury that could be a contaminant get put into the cement and basically get buried in somebody's pavement or something. So they're actually, one cool thing about mining is it takes out these inorganic chemicals. Okay, infectious diseases, organisms, contaminated drinking water. There's 1.6 million people die every year, mostly under the age of 5. So waterborne diseases are the most prevalent all over the world, right? Big issue. Cholera, diphtheria, then the associated ones like malaria from mosquitoes. So it's a big issue. Okay, so there's a slide of some of those waterborne diseases. Let's just look at it. Typhoid, didn't mention typhoid. That's a really lovely one. I hope none of us ever get that. Cholera, dysentery, enteritis, infectious hepatitis, type B, very bad. And then a parasitic protozoa, Giardia. How many people have been hiking in the Sierra or been to Mexico and got a lovely Giardia infection? And then the whole bottom falls out of your world and the world falls out of your bottom, right? So, sorry, that's kind of rude. But that's what we talked about in South Africa. I mean, and it's bad. It takes a couple weeks. I got this a couple of years ago, and it took weeks. And it was really bad. I won't go into the details, but the lining of my stomach came off. And, oh, it was bad. I won't go any further. I think you got the picture. So there, how do we test for it? Fecal coliform bacteria. The thing we don't realize is, we're all good, but all the stuff is in our own, most of the stuff is in our own feces. That's why when they tell people at McDonald's at work there to wash their hands, it's really important, okay? We don't catch it every time because we're pretty resistant to it and needs large numbers. But if sewage goes directly into our water or onto our crops, then we have big issues, okay? All right, major water pollutions, and their effects. Dissolved oxygen, one of the ways we measured this, we're not going to go into great detail on this, but dissolved oxygen is, we bubble water and it's very important to mix water. If you look over at the fish hatchery here, if you actually look at it from this side, you'll see some towers. And the water is actually being pumped up over those and it's bubbling down to pick up oxygen. Because those fish, when they're in there, the trout in that case, need dissolved oxygen. Well, if we put a bunch of polluted water in, nitrates, phosphates, now algae comes along and other things, and they start feeding on those nutrients, but they take most of the dissolved oxygen out of the water. That's why I told you the story was this class. I told the story about the dead fish in the Salton Sea. That's what happens. All those nutrients from agriculture go into the Salton Sea. We reach a point, temperature's nice and warm, and we get an algal bloom, an algae bloom, right? And it kills the fish because it takes the dissolved oxygen out of it. The fish are trying to breathe in the air, but that doesn't work real well. No, that's a bad joke. Okay, all right. All right, flowing streams can recover from a moderate level of degradable water pollutants. Why can flowing streams recover? What's going on here? Let's say I put nitrates in and we had a flowing stream out here. We put nitrates in from my septic tank, which septic tanks put a huge amount of nitrates into the water. And the Mojave River happens to be flowing. How can it take care of a moderate amount of nitrates? What's going on? Well, what's happening is that water is bubbling, it's moving, it's picking up oxygen. How's all this stuff treated? It's treated naturally anyway. So again, the bacteria, the algae that are in our water take care of those wastes. They're eating it up naturally. That's what happens, we'll see in a moment, when we go to Victor Valley Wastewater Treatment Plant. They're just farming bugs, literally. They're just a big farm for bugs to eat up all our wastes. And they do a really good job, except for pharmaceuticals and solvents and things that they don't eat, okay? Right, so oxygen sag curves, I dump the nitrates in. If I measure dissolved oxygen downstream, I think there's a picture of this. So here we go, let's just quickly look at this. Everything's happy, everybody's good up here, fish are swimming along, happy. Does that not look like a happy fish? And then we put, there's the point source pollution, putting a bunch of nutrients, phosphates, potassium, whatever else, nitrates into water. Some fish can handle it, carp, the garbage fish can handle it. But look at the oxygen, okay? It actually goes up here because of that oxygenation there from that flowing water, but then it just drops because this is an algal bloom, and that's what that color looks like, right? Because all the algae blooms, now we have a problem with oxygen, and it doesn't show here, but if it was bad enough, that it actually kill the fish. But in a flowing stream, what happens? The fish just move out of the way, right? They get out of the way. So, then it starts to recover. Look, it's starting to recover here, and eventually it'll pick back up as the bacteria actually, those algae are not a bad thing. That's why I always say to people, if you're going to swim, if you don't know, if you go to a foreign country and you see a little lake and you want to swim in the one that's green, not the one that's perfectly clear unless it's in a mountain. If you're in a city and you see a perfectly clear stream, like my pool, you shouldn't have swum in there, Derek. It was too clean. Oh, it wasn't so clean, actually, was it? With that algae in it. So it means it was healthy. Because there might be some kind of solvent, some kind of really toxic thing in that water that's killing it. So this concept that green is bad, Derek recognized that because he's a very learned fellow. Yeah. All right. Pollution of freshwater streams, still a problem. Untreated sewage, industrial waste, not so much in this country. Only time we get this in the United States is after a big storm. Goes into the sewage plants and basically flushes that out before it gets time to get treated. Okay, so that happens even in this country. Other parts of the world, this is the Ganges, you know, where they go and do their annual ritual of actually bathing in the Ganges. Millions of people, right? And the Ganges is incredibly polluted, and these people are bathing and drinking it because it's part of their culture. Okay, part of the Indian, what culture is, what religion? Huh? Hindu, thank you very much. Boy, that was a tough one. Okay. All right. So, quickly, want to talk about another thing called eutrophication. Write this down. It might be a test question, apart from anything else. Whoop. Eutrophication just means that it's a word for when we artificially or naturally enrich a water body with lots of nutrients. Natural enrichment of a shallow lake, estuary, or slow-moving stream. Okay? So that's eutrophication. Cultural eutrophication is if our culture does it, if man does it. From agriculture, we let we put too much fertilizer on the ground and it goes into salton sea. That's cultural eutrophication. Eutrophication is an increase in the bacterial and algal and life in that water, right? Lignification is the opposite. I don't even know if we go into it. Let's look. We won't have to worry about it if we don't. Lignification happens in Canada. So I was very excited a few years ago. I got to go on I went on a paddling, not in a kayak, but in a canoe, on these gorgeous lakes in Canada, right? And they're all connected, and the water is just crystal clear. And I was like, oh, that's great. And I got started, and then I was like, where are the fish? Twin City fish. Fishing for my dinner that evening, because we were way out there. Nothing. And birds? Oh, there's no birds, other than a few of those really cool birds. I'll think of them in a moment. But anyway, lignification means it's not very rich because it's too cold and there are not nutrients in the water. Okay? And so it actually is not a very rich environment. It's an lignification process where there's not enough algae, bacteria, shrimp, food in the water, and the whole ecosystem is somewhat limited. Not a bad thing, but it just depends where you are. Okay? Pollution in the Great Lakes. This has become a huge issue lately when we look at around Chicago and the issues that they had there recently of water pollution in the Great Lakes. There's another eutrophication slide. There shouldn't be two of them, but that will keep going. Groundwater pollution is what we focus on, and we're going to see, as we mentioned, the chromium-6, which was a solvent that they used to clean the pumps. What they're doing is pumping natural gas from Oklahoma to PG&E, which is up in San Francisco, and they have to compress the gas so that it will be liquid and they can move it easier. And they were using that to clean off, rust from the pumps. They didn't know, actually, at the time, that it was a problem. But then after that, they did kind of try to hide it, which was a bad thing. But they got caught out at that, and they've paid a big price ever since. Common pollutants, fertilizers, pesticides, gasoline. That's why you continue to see gasoline pumps being replaced and their tanks being replaced. Organic solvents. All right, here's a bit of a look at where does this stuff come from that goes into our septic, into our groundwater. The one we're going to focus in on, those all make sense to us, I think. Accidental spills from industry, salt from roads would be an issue. Here we are with a septic tank, okay? And in a moment, we're going to look at the difference between septic tank and an actual sewage treatment plant. Septic tanks are very incomplete, very poor treatment of sewage, actually. And we up here have a lot of septic tanks. And we think that that's probably the biggest reason we have nitrates in our groundwater, not the dairies. In fact, we kind of know that. According to EPA, one or more organic chemicals contaminate 45% of municipal groundwater supplies, so it's a big problem. Arsenic, I think we talked about this already. Arsenic actually dissolves out of rock. So right up in Oak Hills and in Baldy Mesa, and any deep wells around here, probably below 300 feet. My well, I tested it for arsenic because it's at 450 feet and it didn't have a problem. But the EPA, Environmental Protection Agency, we all know what that is by now, right? They established the water contamination levels, and they established the MCL, not the NFL, but the MCL. Okay, MCL, this is really important. So it'll also probably be on a test. So minimum contaminant level. EPA looks at all the research and decides the MCL for arsenic is 10 ppb, parts per billion, okay? And they just dropped that from 50 couple years ago. So that's 5 times less. So all of a sudden, Baldy Mesa, Oak Hills, came into a problem where their ppb levels were higher than 10. So now what they're doing out there, if you live in that area, they're mixing the water. They'll take water from another area, especially their pumps that come all the way from the Mojave River and go all the way across from the adjudicated areas that we'll talk about later, go all the way across. They're mixing the water to get it below this, because if they don't stay below ppb of 10, they're going to get fined, huge fines. Okay. A lot of controversy, because in Bangladesh, China, and West Bengal, and parts of India, they're used to ppb levels of hundreds of times higher than this. Okay, if I remember the figures right, they can be up to like 500 ppb. Okay, it's really high, and they see the effects. So now, how do we determine what the level is? And this becomes the big question. Same with chromium-6. What is the minimum level? The MCL becomes huge, because then we know how to manage the water. So they took years to decide on the MCL for chromium-6. They just decided a year ago it's 3 point something. And now Hinckley, PG&E only has to treat to that level. They don't have to go to nothing as the way we were before, which is kind of silly, because chromium-6, by the way, is also picked up from our rocks. There's higher levels of chromium-6 in Oak Hills than there are in most parts of Hinckley. Okay, just so you know, poor people from Oak Hills, as bad as the people who live in Barstow, right? They get all the bad water. Not really true. Our water is so well controlled, and actually most people believe that like arsenic 10 ppb is kind of ridiculous. But anyway, contaminants, they slowly diluted and dispersed because of groundwater. So what we find in groundwater is we find a plume. So at the Hinckley PG&E plant, they put it in right at one place. We'll see it, we'll look at it. They were leaching ponds. So they took the water that they cleaned these pumps with, and they put them in unlined leaching ponds so it could get into the groundwater. The groundwater there is only about 100 feet down. Okay, they're right next to the Mojave River. It went down, but because it's groundwater, it stays in a plume. So it kind of looks like this. And their plume is only, I think the widest part of their plume that's a problem right now is only about 3 miles wide. Much better than if it goes into a flowing stream, because then it goes fast. Okay? So if you've got a plume, and that's important to know about groundwater pollution. It's actually easier to treat, still incredibly expensive. Remember we talked about earlier in class, got to stop these things going into our environment. To treat them costs huge amounts of money to get the pollution out. Okay? Okay, case study. Is bottled water a good option? It's 240 to 10,000 times the cost of tap water. Some is ordinary tap water. So I'll just give you an example of our friend Arrowhead. You know, they've got the picture, you've all seen it, the bubbling spring, right? And the trout are jumping out and everybody's happy. Well, actually that water comes from a well in San Bernardino. And it's in groundwater that's much more contaminated than where we are. And they, up until a year ago, they could pump it up and bottle it with less restrictions than tap water. This is a great project for somebody to do as well. I've got, on the water one, I've kind of left it open on position papers, but take a position as to whether tap water is safer than bottled water. And you'll find that it actually is. In the United States, in California specifically. Okay? So because the restrictions on it are less, and then of course you got the whole plastic bottle issue on top of that. That's a whole nother level of pollution that's related to tap water. Okay, what are the major water pollution problems affecting oceans? Most of marine pollution happens on land. Okay, our plastic, our sewage, like I mentioned to you before, sewage just gets pumped straight out into the ocean. The big Hyperion sewage treatment plant in LA, Not sure exactly where it is, but somewhere a little bit south of LA. I think it's the biggest sewage treatment plant in the world. Only treats it to secondary level. We'll find out what that means in a moment. Then they pump it 5 miles out in the ocean. To me, somebody should go to jail for that. That's like ridiculous. We treat it to tertiary level, and we'll talk about that, because it's part of the Mojave River adjudication to replace the water for Barstow. So it has to be tertiary, means it's drinking water standard. Okay. All right. So here's where we're talking about ocean pollution. It's a big problem. I'll let you look at that more yourselves. We don't have time to get too far into that. Ocean pollution. Often we see this with algal blooms. Have you guys ever heard of a red tide off our ocean here? Red tide, and they tell you don't eat the shellfish. If you did manage to catch if you had a permit and you managed to catch a lobster, don't eat it in a red tide, because it's a red algal bloom that happens when temperatures are high enough and there's enough nutrients in the water. And that's from sewage and from agricultural runoff. Well, guess what? 5 miles out to ocean, which way do you think that's going to come? It's going to come back to the thing. So we're causing our own red tides, and nobody ever talks about that. And I think for a first world major leader like us, that's kind of like I said, good word for it, it's kind of stinky. Okay. Oxygen depletion in the northern Gulf. This is the Mississippi Basin, sediment, but also all the nutrients coming off the prairies, all this area up here. This is the heartland. This is where we're growing all our crops. Lots of agricultural runoff, all ends up out here. What we ended up doing is we ended up actually destroying a lot of the wetlands. So here comes both the Houston floods recently and the New Orleans issue, and our wetlands and the health of this area down here, our estuaries, was destroyed. And that's why those floods were so much worse. Okay, so take a look at that. That's in your book. Chesapeake Bay, gorgeous place. I have a friend who works there and lives there, and for crab and everything. But they've got huge areas there because of all the people living around, the huge pollution issues, phosphate and nitrates specifically. They have big pig production facilities at the top end, confined feeding operations, right? Feedlot pig production, that makes a big difference. Okay, of course, our friends, the BP explosion in the Gulf of Mexico, that was really nice, in the deep well. And that was another kind of pollution, which is crude oil. And you guys, if you've been to the beach, don't see it as much lately, actually, in the last 10 years, but you get that lovely crude oil on your thing. And it's not like regular oil that you can kind of wipe off. It kind of sticks on and won't come off, and really nasty. Okay, coastal water pollution, prevention, cleanup, making the case we always need to prevent, and cleanup is so much harder if we have to do cleanup, especially in something like crude oil, because it is so nasty and it's just hard to work with. Okay, how can we best deal with water pollution? We can reduce soil erosion, reduce the amount of fertilizer runoff. Really no reason to have a bunch of fertilizer runoff. You don't want to waste it anyway. You want to put enough on there. We call that, and Tim Hayes will talk to you, we call that agronomic rates. Agronomy is the study of growing crops, and agronomical rate is putting on the right amount of fertilizer where the plant's going to use it all up. That's what we're trying to do in the first place. The fact that it runs off, it just means it's bad management. Utilize organic farming techniques, so that would mean we would use organic fertilizers, compost, and things like that, and more stringent government regulations. Okay, Clean Water Act set the standards. The EPA put this place in the 1970s, and they set those MCLs. There we go again, right? For each kind of contaminant, nitrates, potassium, arsenic, chromium-6, those are set by the EPA under the Clean Water Act. Who puts these into action is a good question, right? Got the regulation. Who monitors it? If you take the water class in the spring, we will have the local water board come by. And if you've watched, which I'd highly recommend, you watch the Erin Brockovich movie, the people that they take a major shot at in there as being incompetent and kind of silly, and she ends up charming the guy at the front desk and getting a bunch of information. They are talking about our local water board. Our local region of the California Water Board that does pollution, water quality issues is called Lahontan, because we're in the Lahontan area, and it goes all the way up to Lake Tahoe. It's Lahontan. We have several of our students that now work for them. It's kind of a cool place to work. All right, septic tank systems versus sewage treatment plants. So we're going to look now at primary sewage treatment, which is a physical process, secondary sewage treatment, which is the biological process, and then tertiary or advanced treatment. Okay? Can we improve conventional sewage treatment? Yes, we can use what are called living machines. We can use a wetland-based treatment system. These are called constructed wetlands. We can use, look at this. Come on now. How cool is that right there? We have one of those. You guys got to see one of those. All right. So this is locally looking at septic tanks. Septic tank is a tank, and you put your sewage in there. The problem is it's anaerobic. Okay? Anaerobic as versus aerobic means no oxygen. Anaerobic. It's a different kinds of bacteria and algae, right? And their anaerobic ones are ones that make really stinky stuff happen, and they also don't do a very good job, okay, of treating, getting all that waste out of our septic, right? And then, so what we do after that is we just dump it into a leach field. So you have the septic tank, then you leach it out into the soil. And if that is too close, and the soil has those bacteria in it, and it can treat some of it and filter some of it, but if this is too close to the groundwater, then those nasty things like nitrates are going to go straight into the groundwater. And we have that all along Apple Valley side and Hesperia side of the river up there, where those are all on septic tank. I have a house over that side, and they're all on septic tank. And this is a big problem. We only have, how many people of you in the class know that they're on septic versus sewage? 1, 2, 3, yeah. Pretty good percentage. I'm not sure exactly what it is, but might be close to 50% people who live up here are on septic versus a sewage plant where it goes into sewage pipe and goes to the treatment plant, right? Okay, so we'll talk about that in a moment. Constructed wetlands, natural purification systems. Sewage flows into a passive solar greenhouse. There's houses in Arizona, I'm still wanting to visit them, called earth ships. And they literally treat the sewage inside of the house. I hope they've got their stuff down, but it's interesting. So, you know, you saw what we do is we use gray water. We take the gray water directly out on our plants, but not the septic itself. Composting storage, constructed wetlands. If any of you are lucky enough to transfer to Humboldt State, the town where Lynn was educated, and they have a constructed wetland there. They treat the sewage and then they put it out into a wetland right in the bay to do the final treatment. And we're a little bit ahead of ourselves on this because you guys don't know, we haven't really talked about what treatment is yet. Okay, so this is a living machine. This is what's called aquaponics. You're growing the animals and stuff. This is kind of an aquaponics when you're actually using dirty water to grow plants or animals and fish, okay? And so that's a thing called a living machine. That's a bit of technology you can look up, taking to the next level. So, okay, so what are we talking about? Primary sewage treatment is physical process. We take off all the stuff you shouldn't have thrown down the toilet, any solids, they just get literally screened off the top or they sink to the bottom of a tank. When we go to this, no, we're not going to go to the sewage treatment plant this time.
My class goes today.
The environmental science lab class goes today to the sewage treatment. Secondary treatment is all biological. It goes into these big tanks. You guys will see today. The water is oxygenated, got lots of oxygen in it, and they carefully control what kind of bugs are in there. Bacteria, little protozoas, algae, and they literally eat up all that extra sewage, right? And that's the secondary process. And that can take, if you do it right, can take care of 90% of the dissolved and biodegradable wastes, okay? And that's what it kind of looks like in a diagrammatic. That's not literally how it looks, but that's a diagrammatic thing. Here's a sludge. Just want to point out this one at the bottom here. Sludge digester. That's literally over there. They actually digest that sludge and they produce methane. And that's what powers their pumps to put oxygen back in the water. They have big air pumps, put air back in the water. And this sludge, when it comes out of here into a sludge drying pad, it's called biosolids. So if you ever buy compost and they ask you ask them what's in it, and they say biosolids, that means it's actually originally human sewage. Is it a problem? Absolutely not, because it's been heated to a temperature here, and it's completely safe. Okay, safer than a lot of other things. But that's the cool, let's say, politically correct word is a biosolid. Is actually the sludge that's being digested in what's called a biodigester. And if you take the water class but we produce methane, and methane is a great fuel like propane. Okay, tertiary treatment. Final cleaning process before it is reused, recycled, or discharged to the environment. And this is where we're actually chemically or physically taking out any contaminants. So they have a nitrate treatment facility there at Victor Valley Wastewater Reclamation, VVWR. They don't have phosphates, but we don't have a phosphates. Where do phosphates come from, by the way, in our sewage? They're in soap. Soap is very rich in phosphates, part of soaps, okay? And then the second thing they take out is those bacteria. Well, guess what? Those bacteria that are eating up are some of the ones, E. coli and others, that can cause us health problems. So at the very end, they kill those before it goes out in the environment or is recycled. In this case, it gets put out into the river to go on down to Barstow. They kill those. Lately, they're using ultraviolet light, so they don't even have to put chlorine. The reason you might taste a nasty taste in your tap water locally, that's normally from chlorine, right? Not going to hurt you, but on the other hand, it's, again, a chemical, and there are some issues with chlorine on a bigger scale. Okay, sewage sludge, biosolids, talked about that. There we are talking about if we do use biosolids, sludge, or if it's not properly treated and it gets into the water. Next step, we need to reduce and prevent pollution in both more and less developed countries. Drinking water quality, centralized water treatment plants, lots of water companies treat their water before they send it out. Locally, we don't have to do a lot of that because our water coming from underground is so clean right now. The only one we're doing a little bit of is over in Victorville, treating for arsenic, like I mentioned. There's your MCL. Using laws to protect groundwater. That's the EPA standards. We talked about that already. Clean Water Act. Safe water. Bottled water. Is bottled water the answer? I think absolutely not. And then there's your water pollution solutions. Study those very carefully. How do you prevent water pollution? We've talked about most of this. Prevent groundwater contamination, reduce non-point runoff, reuse treated wastewater for irrigation. So let's talk about that real quick. What are we doing locally to do this? Treated wastewater. If you notice, if you travel around, there's a new sewage plant went in a Hesperia out towards the freeway, and there's one at Otto Park in Apple Valley. they're doing secondary treatment. They're actually doing most of primary, a little bit of secondary treatment. So they're treating it to clean enough that they can irrigate the parks and the golf courses and all of that stuff. And then what's left is going back down to Victor Valley Wastewater Reclamation Authority to get properly cleaned. So they're doing kind of an intermediate place. So don't have as much volume going all the way down there, and then when it's recycled, have to be pumped back up. Okay? And then the 3 R's, 4 R's, refuse. Oh, I like that one. Always forget about that one. So refuse means we have the choice in all of this, and we'll end with this. Thanks for waiting, you guys. We refuse. What does that mean? We're the consumer. So next time I go on a field trip and I say, oh, we've got bottled water for you, and I go up to Sam and I say, Sam, do you like this bottled water? Sam says, no, I don't like bottled water. It's bad. Look over here. I've got my little canister of tap water that I filled up this morning. That's what we're talking about. It's us taking the ultimate responsibility, right? That's the main thing about all of this, is we can make the difference. Okay, thanks you guys.